Hey everyone, and welcome to our lecture on the principle of least privilege. In this module, our learning outcomes are to be able to summarize the meaning of least privilege, identify situations where an entity has more privilege than is needed, and also examine privileges to determine if they are appropriate. So what is the principle of least privilege? Well, it states that entities should only be granted privileges that are needed to perform a job. And an entity is something that we assign privileges to. So some examples would be users, processes, and programs. So why would we want to adhere to this principle? So some reasons we would want to would be system stability. Anytime that we run code under limited privileges, then that restricts the access of what it's able to do. And a lot of the different APIs and functions that could cause a system crash run at a much higher privilege level. So if we can restrict that, we can gain some stability. Additionally, there's system security, and it sort of falls in with the stability, but if a program or process is running at a high privilege level and a vulnerability gets triggered, then that particular process could move into other processes at the same privilege level. So if we are running processes in a very low privilege level, it limits the amount of movement that that particular exploit can take. Next is ease of deployment. It's a lot easier to deploy an application that requires fewer privileges. So an example would be that if we were to install a program that does not need a device driver, we don't actually need to do an installation or a formal installer. But if we are distributing an application that requires a device driver to be installed, then we will need to bundle it up into a formal installer. Lastly, there's data security, and this is just gives us the ability to isolate data from certain users who are not authorized to see that data. So some of the history of the principle of least privilege, Jerome Saltzer is a famous computer scientist. He worked at MIT, and back in 1974, in a Communications of the ACM article, he wrote that every program and every privileged user of the system should operate using the least amount of privilege necessary to complete the job. Now, a couple years later, Unix version 6 was released, and in the login.c code, we could see that principle being applied. Essentially, the code starts with superuser permissions, so root level permissions, and as soon as possible it drops those permissions using the setuid function. So let's take a look at a demo. Here's the situation that we're going to be looking at. We have two users, Alice and Bob, and Alice keeps bank account information in a text file in her home directory. Unfortunately, though, she did not secure her file with the correct permissions. Bob works on the same shared system as Alice, and Bob has a malicious side to him, and he decides that he wants to poke around in Alice's home directory to see what he can find. So let's take a look at what this might look like. So I have two terminals open, and in this terminal I'm going to log in as Alice, and then in this terminal I'm going to log in as Bob. Now on Alice's in her home directory, we can see that there's essentially nothing. There's just a examples.desktop file. I'm going to create a bankinfo.txt file, and this is where Alice is going to be storing her bank account information. So let's say that she's going to store her account ID, whatever that may be, and then an account password. That would be her password to access her bank account online. Alice goes and saves that file and thinks everything is okay. Bob, on the other hand, is working on the same system as Alice, and he decides that he wants to poke around the home directories. So when he takes a look, he can see all of the different users who have accounts on the system, and he goes into Alice's home directory. and takes a look. Well, he sees the bankinfo.txt and decides that he wants to look at that file. And surprisingly, he is able to. So he's able to get Alice's bank account information. Now he can log into Alice's bank and perform transactions as if he was Alice. So let's take a look at why this was a problem and how we can fix it. The reason this is a problem is because of the default UMask in Ubuntu. So the default UMask is 2. And the UMask is subtracted from the default permissions for a file, which are 666. So if we take 2 away from 666, then it's 664. And if we think about what that equates to as far as symbolic permissions, that's read write, read write, read. So we should be able to see that if we do an ls-l. Our bankinfo.txt has the permissions read write, and read. So even though Bob is not Alice, obviously, and he's not in the Alice group, he is in the other group which has read permissions. Alright, so a couple ways we could fix this. We can come in and we can say, you know what? Only Alice needs read-write permissions to this file. So Alice could do that to fix it. Now if we look at the permissions, we can see that only Alice has read-write. Anyone in Alice's group cannot access this file, and neither can anyone else. So now if we're Bob over here, we can just run the same command and we get permission denied. Something else that we may want to consider doing is changing our UMask. So you can do this in your bashrc file, or you can just do it by running the command. But perhaps we change this to, let's say, 66. Okay, so now the UMask is 66. Let me create another file, bankinfo.txt. We'll call this bankinfo2. And we'll just put some data in here and save it. Now if Bob goes to look at the permissions here, we'll see that UMask was subtracted from the 666, and now any file that Alice creates has this only read-write permissions for Alice. So the problem that we saw was that Bob can read Alice's secret file, and the fix was to go in and change the permissions on that file, and then optionally update the UMask so that it doesn't happen again by default. I hope that you've enjoyed the module. If you have any questions, please feel free to reach out to me. Thank you.